Every day, more than 4 million people fly on commercial airlines worldwide. Each year, 1.7 billion people on 25 million flights. Flying is the safest means of public transportation. Accidents are rare, but when they happen, they can be catastrophic. That was the case on September 2nd, 1998. Swissair Flight 111, flying from New York to Geneva, slammed into the Atlantic Ocean off the coast of Nova Scotia with 229 people aboard. Upon impact, the plane was shattered into millions of pieces and spread across the bottom of the sea.
I'd hoped to get my child's body and bring her home to New York. Well, the medical examiner just said no one would be allowed to go to the morgue because he was very frank with us. He was very honest, and he said there were just parts of people.
Rowena Lee White.
I had a funeral with no body.
Alex Wilcox. Petra Wilcox.
Based on one clue, the pilot's radio transmission of smoke in the cockpit, the Canadian Transportation Safety Board launches what would become a 4.5-year, $39 million investigation.
This was the largest and most public accident that the Canadian Safety Board had investigated. They were under an enormous microscope from the very start.
They were faced with the question, how could smoke in the cockpit lead to the crash of such a massive plane?
The legacy of this accident is enormous because we have airplanes diverting and making unscheduled landings at the rate of about 1 a day worldwide for in-flight smoke events. If the cabin of a modern jetliner was a restaurant, it would not get an occupancy permit.
Was Swissair 111 an accident waiting to happen?
Some of the families had trouble believing that their loved ones had died. And I said, just show them some pieces of the wreckage. Not a lot, not all of it, but just some. And they'll realize that nobody could survive the crash.
Can another Swissair 111 be prevented? Crash of Flight 111, right now on Nova. On the evening of September 2nd, 1998, Swissair Flight 111 taxis for takeoff from New York's JFK Airport. The plane is an MD-11, a jumbo jet built just 7 years earlier by McDonnell Douglas. At 8:18 p.m. Eastern Time, Flight 111 takes off, bound for Geneva with 229 people aboard. Then, about an hour after takeoff, a wisp of smoke enters the cockpit.
The first officer noticed an odor, mentioned to the captain, and the captain said, look. The first officer said that he'd get up and take a look at it, and he looked around and he couldn't see anything. There was nothing more out there. And the captain then called the flight attendant from the first class section to come forward and ask her if she had seen any smoke or smelled anything. And she said there was nothing in the first class section where she was working.
The pilots dismiss it as a common air conditioning problem.
Boston Center, Swissair 111 heading.
Then, 2 minutes later, at 9:14, air traffic control receives a transmission from Swissair 111 declaring pan, 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 the international urgency call.
I'm sorry, who's that last call?
Indicating trouble, but not a threat to life.
Boston Center, Swissair 111 heading is calling 13345.
But as the pilot requests a place to land, his transmission is audibly obscured by an oxygen mask. Already 300 miles past Boston's Logan Airport, air traffic control radios back suggesting Halifax Airport only 60 miles away. The pilot accepts, and Swissair 111 is passed over to the Halifax air traffic controller. Runway 06 is readied for an emergency landing.
The air traffic controller notified them that they were 30 nautical miles to the runway. However, they were still not ready at that altitude to land, so they had to lose some more altitude. Then the pilots also mentioned to the air traffic controller that they needed to dump some fuel. And so the controller turned them back towards the ocean to do that.
As the plane heads towards the Atlantic Ocean, Swissair 111 radios again to Halifax. A warbling sound in the background indicates that the autopilot is disconnected. Both pilots declare emergency. It's 9:25. For the next 6 minutes, there is no further communication. Then, at 9:31 Eastern Time, Swissair Flight 111, with 229 people aboard, slams into the cold, dark waters off Nova Scotia. Rescue workers are on the scene within minutes. A furious search through the night reveals the tragic fact: there are no survivors.
Ingrid Acevedo, Pierre-Andre Alain,
Going up there was a compulsion.
Albertson,
I wanted to know where my brother died.
Albertson,
That's all I wanted to know. I wanted to be at the place, as near to the place as we could be.
Miles Garrity lost his brother Pierce and became president of the International Association of the Families of Swissair Flight 111, representing the concerns of those who lost loved ones. One major concern is to make sure the mystery of the crash is solved.
The plane had hit the water so fast, and we knew how many parts it was in, and how just totally destroyed the bodies were, that I always thought there was a good possibility they might not be able to solve it. But it was really important, actually, for me and for everybody else. They really do want to know what caused the loved one's death.
Peter Gultz was managing director of the National Transportation Safety Board, an agency representing the United States in the investigation.
The stakes are enormous in an investigation like this. First, you have the families of the 229 passengers. They need to know that the investigation is unbiased, that it's done quickly, that it's done fairly, and that it's done in a transparent way. Then you have the public at large, who flies on aircraft every day, every week. They need to know that this investigation is going to uncover any fundamental flaws in the system or in the aircraft so that this accident doesn't happen again.
Because the crash is in Canadian waters, Canada's Transportation Safety Board conducts the investigation, with help from their counterparts in the United States and Switzerland. They'll be joined by representatives of the airline industry and manufacturers, including Boeing, which took over McDonnell Douglas, and Pratt & Whitney, the engine maker. Watching carefully are claims adjusters from insurance companies, members of the press, and all those who lost someone in the crash. The first clue in the investigation is the pilot's report of smoke in the cockpit. And now, burn marks on floating debris and on some pieces of the recovered plane indicate fire. But what caused the fire? Equipment malfunction? Terrorism? The answer lies 180 feet below the surface of the Atlantic Ocean. After 4 days of combing the ocean floor, investigators get a break. A diver recovers the flight data recorder, and 5 days later, the cockpit voice recorder. The plane's black boxes. By cross-referencing the aircraft's performance data with the voice recorder, crash detectives should be able to tell what happened after the pilots lost contact with air traffic control. Members of Canada's Transportation Safety Board rushed the boxes to the lab for analysis.
Interface board.
But in a highly unusual occurrence, right after the pilots declared emergency, the recorders stopped working. Nearly all information about the last 6 minutes of Flight 111 is lost. It's a profound setback. Now, to find out what caused the crash of Swissair 111, investigators will need to reconstruct the final 6 minutes of its flight. To do that, they need to salvage clues from the hundreds of thousands of pounds of wreckage lying over 180 feet below on the ocean floor. It's a Herculean task. With winter threatening, the salvage operation goes into high gear, involving more than 4,000 people from Canada and the US. Scallop trawlers and heavy lift ships comb a scattered debris field. Everything is a potential clue. Tangled webs of wire, fragments of aluminum, plastic, cloth, and wreckage from the cabin.
The amount of energy that it took to destroy this airplane into pieces that we can pick up in one hand and have no trouble manipulating. All of that in, I don't know, a third of a second or less. It's just, it's mind-boggling.
Somewhere in these millions of mangled pieces lies the answer to what caused the crash. Investigators will need to piece together the plane to solve the mystery. The clues they already have, smoke in the cockpit and burnt debris, point to fire. But where did the smoke come from? And what caused the fire? David Evans is editor-in-chief of Air Safety Week and covered the investigation from the beginning.
Well, in the horribly grim circumstances of this tragedy, the one footnote of good news is that the airplane plunged into the water, which had the effect of immediately dousing the fire and freezing in time the evidence that would be so crucial to unraveling the mystery.
All of the fire damage that we see is a pre-impact damage. There is no post-crash fire to destroy that evidence.
The fire burned a kind of color code on each piece of debris based on heat intensity, how close and how long it was exposed to fire. If investigators can break the code, it will assist them in reconstructing the plane and locating the source of the fire.
So what we did is we got Boeing to provide us some samples of the actual primer, and we painted these coupons and subjected them to these different heats for different periods of time to see what the color change was.
As investigators increase the temperature and time of exposure to heat, the samples go from a light green to a dark brown.
What this is giving us is an ability to measure the temperature in different areas of the airplane.
The hottest temperatures, in excess of 1,000 degrees, are in the front of the plane. In all, there are about 2 million pieces, bent, torn, and burnt.
But you look for specific landmarks, like this has a pattern on the tape, so that's one thing you can look at. The soot damage on the inside also, you try and match that up. Now, here's a possible. A little piece missing out of here. but I think that's quite possibly a good match. And I'm going to call that a match.
As small pieces go together, forming more identifiable parts, investigators begin to place them onto the jig, or frame of the plane. While they are building it physically, they are also building it virtually. From MD-11 plans furnished by Boeing, the TSB constructs a 3D model.
This CAD model is accurate enough we can actually go in and take physical measurements off it. So when they're reconstructing the jig out there and they want to know where this piece of duct goes, we can actually go in here and measure that out for them, and then tell them right off the measurements where they have to put that piece of duct.
These ducts are from the front of the plane, above the passengers' heads. They are hidden from view in the cabin ceiling. Below them are the first-class galleys, where the flight crew is heating up dinner for passengers. Could a fire have started here?
With the electrical components and the fact that we have ovens in 2 of these galleys, it's definitely a potential source of fire. So we're looking now for fire damage. There's no fire damage inside the galleys. When we get down to this point, the outside of this door, we can see that it has in fact been subjected to heat up here, and in fact the plastic on the outside wall here is starting to melt and come down. The same when we get over to the roof of this galley, the same with the heat damage on the roof of galley 1. All of this is from the top down as opposed to from the bottom up. So our ovens did not play a factor in creating this damage. And that becomes extremely significant because now we rule out a whole bunch of things.
What they can rule out is a bomb, explosion, or fire in the cargo hold, passenger compartment, or anywhere in the lower half of the plane. So the source of the fire must be from above, somewhere in the ceiling. Then, a clue points to the cockpit.
This is our co-pilot seat and our carpets. All we got were just various pieces here, just came in from the sea, and at first they weren't.
On these pieces of carpet, TSB structure specialist Mike Matthew finds melted plastic drip marks, an indication of extreme heat from above.
Okay, well, if we could figure out exactly where in the cockpit these particular melt spots are located, we could figure out under which part of the ceiling they were, and that would help us identify which part of the ceiling was hot.
Melt marks from above the pilots' heads, burned ducts in the hidden attic area, a charred galley roof, heat tests showing higher temperatures in the front of the plane, and not a single piece of burned wreckage in the middle or rear of the aircraft. Armed with this evidence, the TSB concentrates the investigation on the cockpit and forward section of the plane, and in particular, the hidden attic area. A chief suspect in any fire that begins above is wire. 150 miles of it.
Well, through all the wire that we've looked at, we've managed to come across or find 14 wires that show melt damage. Like we have copper wire here, the end of it is actually melted, and typically this would be indicative of an electrical arcing activity.
Electrical arcing is basically a massive short circuit, a potentially lethal event.
This system delivers power through the wires to this bundle, which represents the wire distribution system on an active aircraft.
Armin Bruning has spent his career investigating aircraft wiring and was asked to provide expert testimony on electrical arcing to Congress during the Swissair investigation. His arcing test simulates conditions aboard planes like the MD-11. One condition he finds on every plane is cracks in the insulation on the wires. It's caused by the vibration of flight, chafing, physical contact during maintenance, or just degradation over time. But electrical current from this bared wire can jump to a metal piece of the plane or another wire with damaged insulation. Often, the only condition necessary is normal atmospheric condensation, which naturally occurs in the attic area of the plane during flight. Here, condensation is simulated with a drop of water. Depending upon age, experts estimate there are between 400 and 1,500 cracks per airplane, each a potential cause of catastrophic arcing.
Arcing is just like lightning. It is in fact in the range of 12,000 degrees Fahrenheit as compared to typical flame temperatures, 800 degrees Fahrenheit, 1,000 degrees Fahrenheit. In other words, it's 10 times hotter.
Clearly, arcing can cause fire, but fire can also cause arcing. These wires could have arced when the fire was already raging. Is the heat damage on these wires the cause or result of the fire that investigators are increasingly convinced brought down Swissair 111?
At the one-year anniversary, the bulk of the wreckage was recovered. The notion of an electrically sparked fire on the airplane was pretty well established. The investigators were now facing a major effort to recreate the circumstances surrounding the fire, how it got started, how it took root, how it was able to ultimately bring this airplane down.
We come to reflect on the tragic loss suffered by so many of the families who are here today.
I remember I was with Hélène doing a visit with a family from France. I believe they spoke French. And there was over in J Hangar with a little guy. He was 3 years old, and he was all over the place. And we did the standard tour with some English and some translation. And at the end of that, I always make sure that I ask, is there anything else that you want to know? And the little guy by this time was in with Hélène. And I got it through interpretation, but that didn't take any of the emotion out of it. He asked, is this Daddy's airplane? And Hélène was translating for me, and she said yes. And he said, why is it in so many pieces? And I said to Hélène, just tell him that's what we're here trying to figure out. And that just about blew me away. I'll remember that one a long time. Forever.
More than a year after the crash, TSB investigators returned to where Swissair 111 hit the ocean. They're still missing parts of the plane, wires, electrical components, pieces of the cockpit. In hopes of finding whatever is left on the ocean floor, they rent the world's largest vacuum cleaner. The ship, called Queen of the Netherlands, arrives at the crash site. It rents for about $130,000 a day, and all it will take is 1 day. A metal pipe is lowered into the water. On the end, a head that can run along the seabed, sucking up whatever's there. Everything is drawn into a large holding area. A 2-hour drive east of Halifax is Sheet Harbor. There, the TSB has constructed a 3.5-acre dike. The mud and rock and aircraft parts sucked into the ship's hold are pumped into the dike.
The good news is that a lot of the stuff we're looking at's got part numbers on it.
They hire a team of locals to sift through the debris. Anything that's not part of the bottom of the sea is kept, no matter how small. It's all brought back to Halifax.
These are the things where of no consequence to the investigation. So we're put into this box here, which is our never to be looked at again box.
Here we are some 15 months and 3 days after the accident happened, and the last of the wreckage is finally being sorted out.
Now, with 98% of the aircraft by weight recovered, new evidence is getting scarce, and they still don't know the source of the fire.
That's it. All she wrote.
They take a different approach. Swissair provides an MD-11 which investigators retrofit for a smoke and airflow test. If they can see how smoke circulates in the plane, perhaps they can follow it back to the origin of the fire.
Well, clearly investigators were focusing on the source of the smoke because where there's smoke, there's fire. And we clearly had an uncontrolled, uncontained runaway fire on this airplane.
From the cockpit voice recorder, the TSB knows that the pilots smelled smoke, and then it went away. They also know that no one in the passenger cabin detected any. Investigators equipped the aircraft with smoke generators, video cameras in hidden attic areas, and measuring equipment. They introduce wisps of smoke into the cockpit and cabin and measure the speed and direction of the flow. The results are integrated into a computer model built by the TSB. The arrows track the flow of air throughout the plane. This dense cluster of arrows above the cabin ceiling is next to the recirculation fans. Here, the smoke is filtered out and clean air is recirculated back into the cabin. But because the recirculation fans are doing their job, there can be smoke in the attic of the cabin without passengers smelling it. And worse, fire can be raging above without anybody knowing. Combining the airflow test with a reconstruction of the wreckage, the investigators pinpoint the origin of the fire to a 2 square foot area above the cockpit. But how did it start, and what fueled it? Since the early recovery phases, investigators have noted a strange sight: burn marks on the plane's insulation blankets. The shiny silver covering of this insulation is commonly known as metallized mylar, or MPET. To keep the interior warm and quiet, the plane is stuffed with MPET-covered insulation. In October 2000, the Canadian investigators take samples of the same type of insulation that was in Swissair 111 to the Federal Aviation Administration's testing facility in Atlantic City. The FAA establishes the basis for international standards of aircraft safety.
The FAA has a very sophisticated division that handles the certification of aircraft and the equipment that go into an aircraft. They, along with the original equipment manufacturers, have a procedure in which all of these parts are tested and certified and approved.
Years before, MPET was tested for flammability and certified by the FAA.
Our flame height is good, and we go.
But within seconds, it fails the test. Clearly, this FAA-certified material is fuel for fire.
This is obviously a failure. It has failed flame propagation, obviously after flame time.
The original flammability test was designed in 1972. Since then, the FAA has come up with this new test they're using today.
This is a much more stringent test than the 12-second vertical test, which was required by the FAA, and most of the time this material passed that test.
The new test for newly built airplanes would be mandated on September 2nd, 2003, 5 years to the day after the crash of Swissair 111. But of the 6,000 commercial jets currently flying in the U.S. fleet, more than half have insulation coverings that fail the new test.
I think quite clearly there was an oversight that the testing procedures were not adequate to reveal the danger from this metallized mylar, and it took a tragedy such as Swissair 111 to highlight that more needed to be done in this area.
They also test the end caps of the airplane's ventilation system, another material that, according to FAA standards, should not burn.
Okay, we'll do it slowly, so.
Behind these end caps are the ducts that carry Flight 111's air supply.
This is one of the things we're investigating here is this portion of duct. There's actually a silicon end cap that covers this piece here. And if this silicon end cap burnt off during the fire sequence, we may get fresh air delivery into this general area.
Introducing fresh air could fan the flames of a growing fire.
That's really interesting.
It was down.
Oh, yes.
About 4 seconds.
Jeez.
Yeah.
Look at it. I have never seen a material do that. Look at that.
I think it was a surprise to a number of people, and not just our team. I think that it certainly was a surprise to me. I had no idea that it would burn like that. I never even thought about it, and I think that most of the other pilots in this world would be in the same boat.
I was thinking at the time, well, these things are flying fire traps. I mean, how is it that we can put 200 plus people in an airplane with all of this flammable material? You know, this is the tinder waiting for the match.
Mr. Gurdon, I'm just interested in clarification on your first recommendation in relation to this crash. You're suggesting that some of the
TSB doesn't wait to publish its final report before releasing its findings.
Can you be more specific?
Smoke and fire detection equipment.
The investigators have clearly identified the flammable material that fueled the fire.
Designated fire zones. So, for example,
They make recommendations they believe will prevent a disaster like this from ever occurring again. Foremost, a call to remove MPET-covered insulation from all aircraft.
We've, I believe, uncovered some additional issues here today.
The investigators now have the tinder, but where is the match? They travel to Switzerland to take advantage of an MD-11 that's being pulled apart for a 30,000-hour tune-up. Swissair is removing all the flammable insulation blankets and replacing them with more fire-resistant material. This is a chance for investigators to dig beneath them.
It's an opportunity for us to get a closer look at the wiring. There's a lot up here.
A defect in electrical wiring is still the main suspect for the origin of the fire. The investigators are well aware of the lethal power of arcing. And now, armed with the fact that the material in close proximity to the wiring is flammable, they're even more suspicious. But how do you find one lethal arc out of 150 miles of mangled and burnt wires? They return to Canada to search once again, physically and virtually.
Why this is a very handy tool is it allows us to, in effect, bring the aircraft here in the hangar. I can look at different areas in the aircraft, and what we're looking at now is just what it would look like as if I pop my head up above the ceiling. And you can see that when you visit the jig, we don't have too many pieces up there, but in the actual aircraft, there's lots of wires present. These are the entertainment wires.
The entertainment wires power the in-flight entertainment network, or IFEN for short. They are suspicious of the entertainment system because many of the arcs they found are on IFEN wires. If they can pinpoint one of those arcs to the location where they know the fire started, they'll know what sparked the flames.
The smoke is definitely visible now.
They've got the fuel for the fire. They know how it spread. All they need now is the source.
And if it had have been a knife and wire that was the lead event in the sequence, then how would those wires still be powered?
Unfortunately, none of the arcs can be linked to the 2 square foot area where they believe the fire began.
It's not possible.
It could be the end of the line. After 3 long years, the TSB investigators resigned themselves to the fact that they and family members of those who lost their lives on Swissair 111 will never know the actual origin of the fire. Then, 6 months into writing their final report, investigator Jim Foote sees something that had eluded them.
I remember it quite well. It was on a Sunday, working in here in the morning at this microscope, doing the documentation. And there it was. I mean, as I was pulling this apart, doing the final documentation on the wire, I found it.
What he found was an arc on an Eiffen wire that had not been seen before. Could this newly found arc be the ignition point of the fire? They go back to the hangar with a list of all the brackets they've recovered. Brackets hold wires, and they are hoping to find the one bracket that held the arced wire.
We're searching right now to see if we can find one that may have a potential mark on it associated with our initiating event.
That should be right.
The initiating event, or arc, probably left some damage on the metal bracket. Something resembling a nick or notch, carved out by a powerful surge of electricity.
We don't know if it's there or not. That's why we're going back through the brackets again.
I'm looking in the interior non-identified. And there's a lot of those.
Yeah, 93, 92, 93, 97.
This is one of those never to be gone through again boxes, and we're going through it again.
There it is.
9397?
9397, right there.
Yeah, right back. Why did you pick that?
Is there still one more in here? Yeah, 93, 92. One to go.
Hey, what's the number you're looking for?
93, 92. That's it.
You had to go over on your side, right?
It was on the floor.
They find every bracket on their list.
We're complete.
But none of them show damage from arcing. They do have one other possibility for tracing the arced wire to a specific location in the plane. They go back to all the wires in the suspect area and line them up according to the pattern of fire damage.
In theory, if this is right, we should have a hot spot near 401 and same thing on 410.
Now they hope to see whether the Eiffen wire with the newly found arc fits the pattern.
Look, this is high. There it is. It's right there. So that matches.
After 3.5 years, 280,000 pounds of wreckage, 150 miles of wire, they've tracked the origin of the fire down to within a few inches and a specific split-second, 12,000-degree electrical flash. Armed with every piece of the puzzle, the disaster detectives still need to answer one remaining question. How did the fire cause the crash? The answer is hidden in the 6 minutes that were missing from the black boxes. Piloting a Transport Canada jet, the TSB investigators decide to retrace the final minutes of Swissair 111's last flight.
That first coordinate, we're going to like to descend from 33, and we'd like to descend down to 10,000.
It was here at 33,000 feet at about 9:08 p.m. Eastern Time, 50 minutes into the flight, when the fatal arc must have occurred. Immediately, the MPET-covered insulation ignites. Fed by these flammable insulation blankets, the fire quickly grows and spreads unseen in the attic area. At 9:10, the pilot detects the tiny wisp of smoke.
This is part of the seductive nature of in-flight smoke and fire. It may manifest, it may disappear, it's doing its thing out of sight. And that fire may be taking root as you try and locate the source of the smoke. You're dealing with this seductive demon. It's going to appear, disappear, come back.
Investigators now know the smoke is sucked away by the recirculation fans, but some smoke does re-enter the cockpit. It's 9:14. That's when the co-pilot radios air traffic control that they need to land the plane. Halifax Airport prepares for an emergency landing.
If these pilots knew that there was a fire going on, they would have immediately headed for the airport and done whatever they could to get that aircraft on the ground.
But without smoke and fire detectors, which are not required in the attic areas of airplanes, the co-pilot turns out to sea to lose altitude and dump 30 tons of fuel for a safer approach and landing. Meanwhile, the pilot continues to search for the source of the smoke. He turns off all non-essential power to the cabin. But this shuts off the recirculation fans, and the fire surges forward.
Now the smoke and combustion byproducts would be drawn forward into the cockpit and would basically flow into the attic airspace above the cockpit. The only thing now protecting the crew is the cockpit ceiling.
The fire, still hidden from the pilots, burns through wires and disables the autopilot. The plastic ceiling liner begins to drip.
And when it melts, the fire gases come through. It'd be obvious to the crew that the situation has significantly gotten worse and would be quite perilous.
The last barrier between the pilots and the raging fire gives way. The pilot and co-pilot simultaneously declare an emergency. Ken Adams is a former MD-11 pilot and represented the Airline Pilots Association during the investigation.
All of a sudden, you could hear in their voices the panic as they declared the emergency. They needed to land now. You could hear the autopilot siren in the background just going off continuously.
As the fire rages and the cockpit fills with smoke, conditions deteriorate rapidly. For the next 50 seconds, the pilots can still control the plane with the primary flight instruments. Then the flight data recorder, seconds before losing power, reveals a frightening event. These crucial screens go dark. The pilots are forced to fly with only small, poorly lit backup dials.
It's not an easy combination to fly. Most pilots are used to flying with their normal instruments right in front of them. The standby instruments are a lot smaller than the pilots are used to flying with, so you require a lot of concentration.
But by now, smoke, fire, and soot are obscuring even the standby instruments. The only way the pilots can save the plane is to fly it by sight alone. It is 9:25 p.m. This is when the fire burns through the wires to the black boxes, disabling them. These are the last 6 minutes of Swissair 111.
Okay, we're just now crossing the point at which they declared the emergency. Now descending out of 10,000 at the last known radar point, back ahead.
As their jet continues along the same flight path as Swissair 111, one thing becomes painfully clear.
As we got over towards the sea, it was black and horizonless. That's what we call in aviation a black hole effect. If you're not flying by instruments and you're flying by using outside visual references, it's very difficult to discern up from down and left from right.
The captain's seat was found in the retracted position. So we have pretty good indication that he was not in his seat, which means to me he was actually up fighting the fire. He was probably using a fire extinguisher, but if he didn't have any protection from the toxic gases, then he may have been disabled. Now, we know that the first officer who sits here on the right-hand side of the airplane was flying the airplane. He couldn't really look out front because he had a lot of very heavy backlighting from the fire that was in the cockpit and smoke. It was very dark. He didn't have any horizon. For him to be able to see it all, he probably would have put his head against this side window, and that would allow him actually to displace the smoke, and he could look out.
Although it may never be known for certain, Ken Adams speculates that leaning to the right may have caused the co-pilot to gradually bank the plane to the right. Desperately searching for Halifax Airport, fire raging in a smoke and fume-filled cockpit, black sky above and black sea below, he may have unwittingly rolled the plane over onto its side.
The airplane tightened up and rolled over and impacted into the water.
It's doubtful that anyone saw the ocean approaching as Swissair 111 slammed into the sea.
Humans were just not built as strong as aluminum. For the people in the airplane, they were starting to come apart just as the airplane was starting to come apart.
The investigation into the crash of Swissair 111 was one of the most thorough in aviation history. But after a 4.5-year, $39 million investigation, an insurance settlement of $1.5 billion, an average of $6.5 million for each of the 229 lost lives. What is the legacy of Swissair 111?
Freud said, crystals reveal their hidden structure when broken. And that's why accident investigations are so important, that we do them thoroughly, we do them properly, that we take our time. We are presented with a fractured crystal. We have a window into the internal structure of design, checks and balances, protection, and safety.
The Canadian Transportation Safety Board made 23 recommendations. These include installing smoke detectors and video cameras to reveal hidden fires before they spread, streamlining the pilot's smoke checklist, and implementing a firefighting plan for pilots and crew, increasing the size and visibility of standby instruments, providing black boxes with backup power supplies, and increasing the recording time of the cockpit voice recorder, inspecting aircraft wiring, and setting a higher standard to prevent arcing. And perhaps most important, new flammability standards and the removal of MPET-covered insulation and all flammable materials throughout the aircraft. But safety investigators make recommendations. Only civil aviation authorities, like the FAA, can turn them into regulations. Few of the Canadian TSB's recommendations have been fully implemented. For example, the FAA gave the airlines 4 years to remove flammable MPET insulation, and then at the airline's request, extended the deadline by a year until June 2005.
Now, what do we have in the airline industry? We have what I would call a confederacy of complacency. The problem is that the hazard continues to this day.
MPET, the material that fueled Flight 111's deadly fire, remains in many McDonnell Douglas airplanes. But the problem goes beyond MPET. Other brands of flammable insulation coverings are in thousands of other planes, the majority of the U.S. commercial fleet. AN-26 Mylar in Boeing jets, foam insulation in Airbus, to name a few. The FAA has not set a deadline for their removal. Another disturbing fact, the airline industry and the FAA knew MPET was flammable years before Swissair 111. In 1993, an MD-87 jet was engulfed in flames while taxiing on a runway in Denmark. Then in 1995, an MD-11 in China caught fire. Both fires were fueled by the same type of insulation blankets that were on Swissair 111.
There have been a number of accidents involving burned insulation blankets on U.S.-built aircraft flown in China. The Chinese authorities had contacted our Federal Aviation Administration and advised them that, guys, you may have a flammability problem here. Action taken? None.
In both these major airplane fires, everyone escaped with their lives. A case study in what some call the industry's tombstone mentality, the tendency to ignore a safety problem until lives are lost. But now lives have been lost. The lives of 229 people aboard Swissair 111. And still, the TSB's call for an integrated firefighting philosophy is being ignored.
And what the Canadians figured out is, hey, wires can be a problem. You ought to make the environment around them so it is at least fire resistant. And you ought to have things like the smoke detector that I have in this house to let people know, hey, there's a fire going on inside the walls of that plane.
We're presently having new airplanes designed. They're on the drawing board. Boeing has one. Airbus has what they call the Airbus 380, which is going to be a 550-passenger airplane. The regulations haven't changed. They do not have to provide any more fire detection or fire protection that we had on Swissair 111.
What strikes me is that so many of these accidents about which I have written over the years had precursor events that, had action been taken, they could have been prevented. I haven't seen one yet where structure and systems were involved where it wasn't avoidable and preventable beforehand. And therein lies the tragedy. Therein lies the culpability.
As we come to dedicate this memorial, we give thanks for the lives of those from Flight 111 who died off these shores. Jonathan Wilson, Brigitte Vaprogtigar, Marino Zenios, Urs Zimmerman.
To see the companion website for this program or to find out more about NOVA, visit NOVA's website at pbs.org.